Let's talk about iOS mobile apps, what they are, and what you need to know as a product manager. So iOS is the mobile operating system which powers the iPhones, the iPads, the Apple TV, and all the other Apple devices, Apple mobile devices which are coming up. This was launched way back in 2007 with the first iPhone. iPhone iOS apps are sold in Apple App Store, as you would all know, and the programming languages which are used are Objective C, C++, and Swift. But now it's all Swift. Objective C has taken a backseat, but the original iOS was all about Objective C. So, how do you take an idea to an iPhone? Essentially, it goes through 6 stages. Effectively, it goes through a discovery of an idea, which is a separate topic altogether. uh, then you will refine the concept, you'll refine the objectives, you'll refine the idea, you'll create a technical spec document, then you'll wireframe it, then you'll design it, you'll create a prototype, you'll use a software like Sketch to design the prototype. Then you will pass this on to the software architect, if there is one, or the engineer. Then it will get coded in Xcode. Xcode is the IDE. What is IDE? I think of IDE as a software in which you code. Okay, it's an integrated development environment. So it has everything integrated. You can code in it, you can test in it, you can do plenty of things in there. So you can use Cocoa Touch, Objective C, and Swift to code your entire app. The front end is here. The back end is essentially some server which is providing the all the data that the front end requires. Okay, so you'll create the code that brings the app's functions to reality, and then you'll finally test it and you'll launch it. Okay, and the cycle repeats. As a product manager, you'll be typically responsible for the first 3 steps, but a lot of things that you're going to do, the objectives, the idea refinement, and the technical spec document, is going to be dependent on the design and the coding that is possible in an iOS app. So an iOS app follows MVC design very closely. What's an MVC design? Well, MVC design stands for Model View Controller Design, and it's not exactly a design philosophy, like design not in terms of UI UX, but design in terms of more of software architecture. How do you design? How do you build a product? How do you build a code base which follows Model View Controller, which follows scalable architecture, I'm sorry, scalable architecture. And model view controller is one of the most popular ways of building that. And it is not unique to iOS, okay? Whether you're building a typical traditional LAMP based website, or you're building Android app, or you're building whatever, MVC is a agnostic framework, or I should say a philosophy rather, to your design your products. Okay, so in a nutshell, iOS apps are built with objects. Okay, the building blocks of code that are organized with the model view controller design pattern. Okay, it's a pattern. MVC paradigm is a pattern that breaks down code into 3 core functions: user interfaces, which are called views; models, which are the data; and the software that communicates between the two, which is the controller. Right? So in a typical iOS app, model is a data object, view is the user interface, and controller is the app's behavior. Okay. So if you break this down, so model is the data object, okay, and it gives the controller data, okay, defined in classes to populate the view. So what should be shown in the view is handled by the model. Okay. It is built with framework classes, or you will write custom classes. So basically, you'll use either pre-packaged classes or you'll create your own custom classes. This is supplied by Foundation Framework. That is, iOS has certain existing framework which can be provided to the app, which is called the Foundation Framework, Core Data Framework, plus certain APIs. The controller controls the app's behavior. So controller controls the flow of application. Okay. So apps are based on event-driven programming. That is, if something happens, then do this. Okay. So the controller receives and processes and returns the event. So if something has happened, this information is passed to the controller. The then controller decides that what needs to be done next. Okay. And segues is another term which you'll see if you're ever chatting with an iOS developer. Segues is one of the most common paradigms in iOS development, and it defines the flow between views. So think of one screen, think of second screen, and how exactly the flow is happening between first screen and the second screen. Let's say there's a search screen and there's a product details screen. So when you click on search, when you click on one of the items in the search, what happens or how exactly the data needs to be passed from the search screen to the product details screen. So segues determine the design as well as the data that needs to be passed between the two views. Okay. And Cocoa Touch Foundation framework is provided by iOS to enable to build this controllers. And finally, views are the graphic user interface, the things that you interact with, the screens that you interact with. So each screen of an app is a view. Okay, and views display the content and are populated by the controller. The controller decides it, the model supplies the data. So model supplies the data, controller controls the stuff that needs to be shown on the view, and it includes buttons, text, fields, whatever needs to be done to have a very good experience. Okay, views are described in the storyboard. Storyboard is another term which you will come across very often. It is assembled in the interface builder within the UI kit. UI kit is provided by the iOS core functionality itself. Right? If you look at this interaction, this diagram here, so effectively the model contains the data objects which provides the documents. Effectively, document is essentially a set of data which is provided to the controller. The controller includes UI application, okay, and the application delegate. The application delegate is a term in iOS which is responsible for uh, right, which is responsible for the view controller. That is, uh, what should be shown on the screen is decided by application controller, application delegate. And this application delegate passes the information to the view, and view is handled by this UI window. Okay. So in a typical iOS app, three things matter, which is UI application, which is this one, the app delegate, which is this one, and the app launch cycle. Okay. So UI application is responsible for the event loop. That is, it kind of keeps listening to what is happening on the screen. If the user is clicking on something, or if the user is doing kind of any kind of gesture, it keeps listening for that. As soon as that has been heard by UI application, it passes that information to application delegate. The application delegate listens to it, realizes that okay, the user has, let's say, swiped from left to right, and it knows that what needs to be done on that gesture of left to right. It passes that information to view controller. View controller then passes this information to views and UI objects. That is, the left to right has happened, so you need to change the screen, you need to show a different button, you need to do something else. Okay, and the application delegate passes this information to UI window to change the screen view itself if needed. Okay, from the legend here, you can see that the greens are the custom objects that you have to design, you have to develop it. Blue ones are either system or custom object. They can be anything. View controllers, you can create your own view controllers. And the orangish ones are the system objects. That is, you don't play around with them. Okay, system has provided it. iOS has provided it directly. Okay. A typical iOS architecture would look like this. It will have, similar to Android, will have these layers. The core OS is the bottommost layer. The core OS layer provides the core Bluetooth framework, the acceleration framework, the external accessory framework, security services, local authentication, provides all of these things. Okay, it is the core OS layer which kind of provides you access to the hardware, any external accessory that has been attached, Bluetooth, security, etc. On top of this is the core services, which is like address book, CloudKit. CloudKit handles all the cloud services of Apple. Core data, core foundation, core location, core motion. As the name suggests, I mean, core motion is more to do with how the phone is moving around, right? Which can be used for healthcare apps, wellness apps to detect whether the person is running, walking, doing whatever, right? Then there is foundation framework, which is kind of, as the name suggests, it's a foundational to a lot of other things that an iOS app is capable of. Then there's HealthKit, there's HomeKit, and on top of this is the media layer, which is responsible for the graphics framework, audio and video. Anything that is happening on your phone, for example, if you're running a YouTube app, media layer has a lot of contribution to it. And then on top of it is a Cocoa Touch layer, which is responsible for the final interface. This is the one which provides the UI kit framework, Twitter framework, push kit, which is responsible for push notifications, map kit, which is responsible for the map, iAd, which is responsible for the advertisements that are available on certain apps, the in-app purchases and stuff, event kit, game kit, etc., etc., etc. Okay, this is the typical layered architecture of iOS. A typical In a typical scenario for a regular app, you would be typically only working on the Cocoa Touch layer itself. You will not go very deep. But for other apps, you might have to go deeper, like media layer, or you might even have to touch the core services. But you can't move around. You cannot play around with core services too much, but you can play around with Cocoa Touch a little more. I mean, these are the things that are provided. But yeah, uh, so this is all about iOS architecture, right? So to conclude, iOS apps and Android apps have very similar approach in terms of their MVC. The overview is just something similar, except Androids have activities, iOS uh, have UI application and event loops. Okay, so their approach or their definition of their solution towards the same problems is very different. Okay, but effectively they follow the same fundamental principles. The dynamics is roughly the same. Okay, they both follow MVC. So hopefully you would be in a much better position to actually know what's going on or what your iOS developer is talking about. There's a lot more behind the scene about iOS development as such, but this is good enough to know as a product manager. That's it for now. Thank you.